Hello everyone. Let us see what are queuing theory or waiting lines in this video. A waiting line or a queue consists of people waiting to avail some service facility. A queue consists of two components, customers who come to avail the facility and server who makes the facility available for the customer. A working of a queuing system is as follows. Customers come and join the system. They arrive and stand in the waiting line. They are taken up for service by the servers one by one, and once the service is completed, they leave the system or they exit from the system. So a customer waits in the queue and then in the service and then leaves the system. So a system comprises of the waiting line as well as the service of the customer. If waiting time of the customer decreases because there are many servers, the idle time of the server will increase, and if there are less number of servers, to decrease their idle times, the waiting time of the customer may increase. Hence, queuing theory or queuing management is to obtain a perfect balance between reducing the waiting time of the customer simultaneously while reducing the idle time of the server. Queues not only comprise of human beings, but it may also consist of machines at the repair center, cars in the car park, letters to be typed at a typist's desk, or goods to be loaded, unloaded, etc. There are different types of queues that we can come across. The first is a single server system which we see at any general booking counter, where there is one server and a single queue where people come and join the queue and avail the service facility from the server. Second type is a parallel server system where you can see that there may be multiple servers and one queue, or multiple servers and multiple queues. Multiple servers with multiple queues is seen generally where there are lots of booking counters. But multiple server with one queue may be observed at airports where there is a common queue for baggage check-in, and as and when the server becomes free, the customers are guided to the server who becomes free for check-in in the luggage. Also, there is one system called as a series server system where a customer has to go through several queues before the service gets completed. He may have to wait in each queue with different service time, different waiting time, different arrival rate of the co-customers. For example, at the airport, unless you enter the premises where you will find a queue, scanning of baggage, baggage check, security check and boarding entirely completes the process of a customer traveling in the airport, at the airport. So the customer has to go through each and every facility which is given here in the sequence unless he or she boards the flight and starts traveling. A typical queuing system is characterized by input pattern, which is nothing but the way in which the customers arrive and join the system. The service mechanism is the way in which they are served. Queue discipline is the discipline or the manner in which they are picked up for service. Behavior of the customer, capacity of the system, and capacity of the calling source. Let us look at these one by one now. An input pattern is the way in which the customers arrive and join the queuing system. Now, the customers that arrive at a queuing system are beyond the control of the queuing system. They may come from any place at any rate. Hence, arrival of the customers is nothing but a random event, and hence the number of customers arriving at a system is a random variable, because you cannot control the rate at which customers arrive at a serving channel. Second is the service mechanism. Each customer may require a different service time depending upon the type and nature of the service that the customer wants to avail. Hence, a service mechanism is also a random variable, and we need to have convenient standard distributions for input pattern as well as service mechanism. There are different types of queuing models which are studied for different types of random probability distribution of these two random variables, and there will be several models depending upon different combinations of input pattern and service mechanism as well. Next is the queue discipline. Queue discipline is the manner in which the customers are picked up for service. A general queue is observed where there is a first come first served system, where whoever arrives first at the service channel is picked up for the service. It is also called as the first in first out system. Next is the last come first serve or the last in first out, and this is observed at various places, like if there is a stack of books, the one which is stacked last will be picked up first, and the one which is picked up last will be the one which was stacked first. Also, you can see the goods which are loaded and unloaded. The goods that go in first go at the back, and the ones which go in last will be removed first, and the ones which went in first will come out last. Also, you can look at the heap of the letters to be typed at the typist's desk. Unless there is a priority or urgency of a letter, the typist will start typing the letters in the reverse order in which they are placed on the table. Next is the service in random order, where there is no fixed discipline of picking up the customer at the for service at a service channel. This example can be viewed or imagined or visualized with the help of customers waiting at a bus stop without any proper queue. So anybody who is swift enough to get into a bus will board the bus first. Maybe he or she has arrived at a later timing. The general queue discipline is a discipline which does not speak of any of these the previously seen disciplines, and it is observed that the average waiting time of the customer in the system is independent of the queue discipline selected, and hence a general queue discipline can be assumed. Then there are customer behaviors. The average waiting time of the customers and the variance of waiting time also depends on the behavior of the customers. A typical customer may behave in either of these following ways. First one is balking, where the customer arrives, looks at a long queue and does not feel like joining such a queue at all, and leaves the queue because he is not interested in waiting, does not have any patience to join the queue at all. Second is reneging, where the customer comes, joins the queue, becomes impatient and leaves the queue half the way through, and thereby reduces the waiting time of the subsequent customers. This is called as reneging. The next type of customer behavior is jockeying, where the customer moves from one queue to another in order to obtain service at a faster rate, thereby fluctuating the average waiting time of the subsequent customers. Next is the type of the behavior called as collusion, where two or more customers may join together and only one of them may stand in the queue, wait in the system and avail the service facility for the entire group. This is known as collusion. This pattern is typically seen at cinema houses, where customers may come from different places, meet there accidentally, and only one of them may join the queue to buy the tickets. Then there are priorities, where the priorities are given to senior citizens, handicapped people, etc., where the waiting time of the other customers may change. This was the customer behavior. Now let us see the capacity of the system. Capacity of the system may be finite or infinite depending upon the service facility being made available for the customers. If there is a lot of waiting space, the capacity of the system might be infinite. But in car parks, in hospitals, in cinema houses, there is a finite capacity. There is a limit on number of customers being accommodated. Hence, it comes under the finite capacity of the system. Next is the calling source. Capacity of the calling source may also be finite or infinite depending upon where is the queue generated from. A calling source is a population from which a queue is generated. If this population is finite, the capacity of the calling source is said to be finite, and if the population is infinite, the capacity of the source is said to be infinite. In this example, in this image, you can see that this is a particular office or a lab where there are a set of computers, and these computers form the calling source. So if a repair is generated, the repairman will have the computers coming only from this group of computers. Hence, this is an example of finite capacity of the calling source. But at normal ticket windows, customers may arrive from any corner of the globe, and hence the capacity of the calling source is said to be infinite. Also, there is an infinite waiting space for such infinite calling source. We can find the applications of queuing theory in the following examples: telecommunication, traffic control, sequence of computers, predicting computer performance, health services, airports, and manufacturing systems. In fact, queuing theory was first developed and designed at a telecommunication center, that is at an operator's telephone board, where telephone calls come simultaneously at many occasions and they need to be answered one by one in the order.